So let's talk about multiplication. I think when every parent gives birth to a child, they think to themselves, the one thing I have to do with them with math in their life is help them memorize the multiplication math facts. Well, I'm here to share that there's another way of going about it that builds flexibility of thought and also follows them through their math journey with even larger numbers, decimals, and fractions as well. So there are four aspects of the math fact fluency. There is, of course, the accuracy and the relative speed, but also that flexibility and the efficiency. And I want to share with you what this looks like with multiplication. Dr. Nikki Newton wrote a book called Math Running Records in Action. I do a lot of consulting work in districts on interviewing kids about their thinking and the progression of strategies we can get them on to find out where they're beginning to struggle and help them move forward from there while building their number sense and building their understanding of the multiplication operation itself. So here's a suggested progression of the math fact journey for our kiddos for multiplication based on the research Dr. Nikki did. So there are a set of foundational facts. So the times 0, 1, 10, 5, and 2. We can have the kids master those first before we go on to the higher facts. It would be fabulous. Now, this is not to say in this progression that kids might not know their doubles before their tens. It's just a suggested progression of exploring these strategies and these number relationships with the kids. So getting those foundational facts in place first. Now, the 2 comes next because in the end of that progression, because we can capitalize that on this relationship to talk about what multiplying by 4 means. Multiplying by 4 could be double of the 2s. And then even multiplying by 8 next, because you can think of that as being doubles or 4s. So again, it's capitalizing the number relationships and building that comfort zone with the kids without exposing them to all the math facts to memorize or let's say to work on. We want kids to be able to think flexibly and build their understanding of the operation of multiplication itself. So here's a chart that I created showing the journey of multiplication math facts. And there are 2 different journeys here. One journey, typically what's happened, is our kiddos will begin by counting objects. So then multiplication, they count them one by one. Then they progress to skip counting, so counting in groups. And very often that's where we tell the kids now go memorize them. So they fall back on their skip counting a lot when they're trying to find facts that they don't know because it's all they've done to think about the relationship of these number facts. Now, if you go up this journey here and get to the skip counting, that dotted line takes you to the mastery of memorization. And at that point, the kids have memorized. And now some kids can do that fine. Other kids struggle with memorizing of them. And so when I'm interviewing kids with the math running record and I ask them, let's say here, 8 times 7, and I ask them, how do you know it? They'll tell me, well, I just learned it. And I'll say, okay, what about a friend who doesn't just know it? What would you tell them to do to efficiently get that answer? They'd say, well, I'd tell them to get flashcards and memorize it. And if I ask them a larger fact, let's say 4 times 17, those kids actually do tell me, I haven't learned that one yet. So going down the road of learning multiplication math facts by memorizing them only and not connecting it to number sense and strategies limits the kids in their thinking. So another suggested pathway for our kiddos then to build their number sense and their flexibility of thinking is after the skip counting, we can work on breaking apart the numbers into smaller chunks that we know. So for example, in the upper left-hand corner, these derived facts, the 6 times an 8, one way I could think about that would be to think about that 6 as broken apart into 5 groups and 1 group. And if I know 5 groups of 8 is 40, I know one more group makes the 48. But listen, my brain likes to break apart the 6 into 3 and 3. I can do 3 times 8 is 24, and then do another 3 times 8 for another 24 to get to my 48. Or maybe my brain works about dividing my 8 into 2 groups of 4. And 4 sixes is 24. Another 4 sixes is 24. And that makes my 48. We're not trying to dictate to kids what strategy you use and when. It's exploring these numbers and having them build their own flexibility of thought of what works for their brain. And by doing so, when I ask kids who have developed automaticity with their facts, I will ask them, how do you know what 8 times 7 is? Oh, I just know it. What would you tell a friend who didn't just know it? Well, I would tell them, well, they could double their 4 times 7, or they could double the 7 times 2, double that to get 4 times 7, then double it again to the 8 times 7. They have some flexible strategies to explain it to a friend who doesn't know it. Because the goal is that kids will actually know it. They'll retrieve it from memory, but that's different than memorizing them. When it's not attached to any memory and any connectedness of knowledge, our brain will prune it, which is why a lot of kids memorize things for the moment, and then they are losing it from long-term memory. It never got put in there. But for building new neural pathways in their brain of thinking about these numbers in flexible ways and in partial products, we're building their knowledge and these neural pathways for their brain. Now, when I ask those kiddos who have gone down that other journey of the math facts, and I ask them, how about 4 times 17? They're not afraid of it. They actually will say, well, they might not know it, right, offhand, because who memorizes all the products, but they'll say, well, I know that 2 17s is 34. I could double that to 68. So they begin having some flexibility of thought, and they're not afraid to try harder problems. They don't say, well, I didn't learn 2 digit by 1 digit yet. They're willing to try it and realize that's a part of the journey, and that trying those new strategies, like that beach path in their brain, try new things. You might make a mistake, but that's okay. You're deepening your understanding and your learning. So again, here's a chart from Pam Harris of developmental reasoning. Now, when our kids are going through this journey, if they are skip counting and they stay at skip counting, where do you think they are on this progression? They're in additive thinking. They're not in multiplicative thinking. By moving them into the multiplicative thinking of breaking apart into partial factors that we know and exploring the number of relationships, we're moving them into that multiplicative thinking where they want to be, grades 3, 4, 5, because we're multiplying decimals and fractions as well, and that's going to help them in that journey. I want to go over a few of the strategies you may not have thought about how we can use for some of these particular facts. So multiplying by a 5, very often kids skip count by 5. It's very easy for them to do, but they stay with that. And when I ask students 5 times 9 and they don't know it, they do skip count by 5 starting at 5. It becomes very inefficient. So by using visuals here, we can encourage kids to use facts they know and maybe skip count on from there. So if I know 5 5s is 25, I could do 2 more to figure out 7 5s. I've also had some students look at the clock. I say, well, what did you just do there? They're like, well, I know that 7 is the 35th minute. And so 7 times 5 is 35. It's a very creative way of using that to help them. But I have found one something really powerful of using the 5 being half of a 10. I've been doing a lot of mental math work on middle school level problems with decimals and things. But I'm doing much more than I ever thought I could have done. And this was coming into play a lot in my life, that 5 is half of the 10. So for example, 8 times 5. If you think for a moment, 10 times 8 is 80. So 5 groups of 8 must be half that, which is 40. How about 16 times 5? Well, what's 10 times 16? Well, I can think of that place value. It's going to be shifting a place value position, which is why that 0 gets put in there for that ones place to hold that position. And so I know 10 times 16 is 16 tens, which is 160. Half of that is 80. So 5 times 16 is 80. What if I do it this, 246 times 5? Well, if I've learned that 5 can be half of 10, I might say, well, 10 times 246 is 246 tens, is 2,460. What's half of that? 1,230. I mean, it opens the door to more possibilities when we're exploring strategies with our kids. Using 8, the idea we can use our doubles, that doubles, which a lot of our kids do know, we can use that for our 4s, and then our 4s we can double to get to the 8s. So here's, again, another math flip from Berkeley Everett. You're seeing an array of 4 by 8. Now, if I figure out that that is 32 dots, how could that help me solve this one? Well, this array, you can see the same one is right there, that 4 by 8 array, and I know that that amount is 32. But look, it's just doubled. 4 groups is half of the 8 groups, right? So I can double my 32 and get 64. Very cool and powerful. Multiplying by a 9, very often I find kids will show me their fingers and they'll do a fingers trick. But a lot of kids actually do the trick and then they do it incorrectly sometimes. So I've had students tell me that 8 times 9 is 27 because they put the wrong middle finger down. It's like, plus the finger trick only works with single digit math facts, and I want to expose them to more thinking than that. So here's an example of a 10 frame the kids are familiar with that structure of a base 10, their base number system. So if I think about there being, let's say, 10 groups of 4, that would be 40. I'm pretty comfortable with that. So 9 groups of 4 must be 4 less than that, and it's 36. Now, if I encourage that thinking, I can forward that to larger numbers. I'll show you an example of that in a couple minutes. Multiplying by a 7 can be pretty scary. Get some pretty high facts. But a 7 can always get broken apart into 5 groups and 2 groups. And that's a comfort zone for our kids. We can do the multiply it by 5 and then multiply the number by a 2 and put those 2 partial products together. Very powerful there. Now, for our flexibility of thought here, so I showed you the 6 times 8. And again, we can have these kids break apart these numbers in flexible ways and using colors to do that. That color can visually see it. There's not just one right way of figuring this out. We're going to get to our 48, but in a variety of flexible ways. Let's think for a second about the algorithm. So 45 times the 16. Let's think of the thinking process in the algorithm itself. I've got a single digit math fact of 6 times 5. That's 30. Now I go to my 6 times my 4. Now it actually is 6 times 40, but it's hidden from me in this algorithm, right? So I know that 6 times 4 is 24. I add 3 more. I write down my 27. So it's really 270 that I came up with. So it works with the place value, the way the algorithm is set up. Now my next step is to get rid of that 3 that I had to write up there before, because I'm now at a new set of computation. I've got to put a 0, and I will ask students why, and they'll tell me my teacher told me to. They're not realizing that now they're multiplying by the 10, the 45 times 10, and putting that 0 as a placeholder in there. So I get a 0 in my ones place because I'm multiplying by a multiple of 10. So I know it's going to be a 0 in the ones place. I then do the 1 times the 5 and the 1 times the 4. I add my two partial products together and I get 720. Now that works. That algorithm works. And we will need algorithms at some point, right? There's going to be some times where other strategies aren't going to come into play and using that algorithm will work. But when we do this too early in our kids' journey, we limit their thinking to try out harder numbers and play with numbers. So I want to show you a few of these strategies here. When you think about that algorithm that we just did, that was all what it may have been additive thinking. They may have been skip counting and figuring out their basic facts. The algorithm of multiplication includes single digit multiplication facts, and very often the kids are skip counting for those facts. So staying in additive thinking, even though it's in the context of a multiplication problem, their reasoning is in additive thinking. So we want to move them into that multiplicative reasoning. How do we do that? Well, one of my favorite things to do is a math strat chat. Every Wednesday night, Pam Harris, who's a consultant and living in consultant in Texas, she will provide a problem for us to do, and we're not allowed to use the algorithms and procedures. And then everyone beneath it puts their thinking strategies, and then you can learn from other people and try that strategy out the next week. It's been really, really fun. So 45 times 16, how else could we explore 45 times 16? One really powerful multiplication strategy is to double and halve when giving our two factors. Now, if you don't have an even factor, of course, that won't work, because it won't work with every single one. But this number relationship here of double and halving can be really powerful in a lot of cases. So I'm trying to figure out 16 times 45. What if I broke that rectangle in half, that area of that total product there, and I slid it over to the right-hand side? So I didn't change the area inside that rectangle. I slid it over to the right. What are the measurements now of my rectangle? Well, I've halved my 16 to 8, and I've doubled my 45 to 90. Now, 8 times 90 is much easier for my brain. It's 720. Double and halving, really powerful. Here's an example of an area model. I want you to see this because it's really hard to do this mentally and do all 4 partial products in our brains. But this, you may see your students coming home and working on that on their homework. It is an incredibly powerful strategy because this is going to work with them with fractions and decimals and even polynomials in high school. Just trust me on that. So it's a really, really powerful model. So I've seen a lot of things on Facebook kind of bashing this method, but it sets a foundation of really great thinking for your kiddos. So that's one way we could do that. Another way is thinking about this, recording it on, say, a ratio table of thinking about, well, if I know I have one group of 16, it's 16. Now I can use that of, well, that means that 100 groups of 16 are 1,600. I'm trying to get to 45 groups of 16, and I'm trying to use half of that 100. If I know 100 groups is 1,600, 50 groups must be 800. I have just determined 50 times 16 being 800, and that was a very easy, relatively easy place of understanding my multiples and all, right? So that's 50 groups of 16 is 800. So I know 45 groups must be less than that. Well, I got to take away 5 groups of 16. If I know 10 groups of 16 is 160, then 5 groups of 16 is 80. And if I remove 80 from 800, it's 720, right? That's really powerful thinking as multiplicative reasoning and building their understanding of what comes in grade 6 in ratios and proportions. It's really powerful. There was a number talk I did once in a 4th grade classroom in Berlin, New Hampshire, and I was asking them 45 times 16. This is a really great problem to do with the kids. And one kiddo said, well, I know it's 720. And as always, I asked him, how do you know? He said, well, I know there are 8 45-degree angles in a circle, and that's 2 circles worth. Since a circle has a 360 degrees, is double that, 720. And that moment for me was a mic drop moment where I realized the power of giving kids the chance to think about these in other ways than an algorithm. If I had asked those fourth grade class to get out whiteboards and figure out this answer, they all would have done the algorithm. Some would have gotten it wrong, some of them would have gotten it right. But I opened up an opportunity to think flexibly about numbers, and they did other strategies. And this kid have made a connection with mathematics that I never would have, because my mind has been limited to the algorithms that I was taught when I was growing up. So, really, really powerful stuff. One last example I want to show you here. Let's say we have 8 times 6. Well, if I figure out 8 times 6, however I want to get there, it's 48. Can I use that to help me figure out 8 times 60? Well, yeah, it's going to be 8 times 6 tens, right? So it's going to be 48 tens, which is 480. Can I use that to figure out this? Now, that might look pretty scary to kids. 8 times 59. But if we do these kind of strategies with our kiddos and get them talking about their thinking, 59 groups of 8 is 1/8 less than 60 groups of 8. So if I know that 60 groups of 8 is 480, if I remove 1/8, that is 59 groups of 8. So I get my answer at 472. Really giving a chance for us to think, for these kids to develop their understanding of multiplication and think of much larger numbers, and do flexible thinking in their own heads sometimes as mental math, rather than getting locked into the algorithm, which is single digits. So, as a summary for multiplication, then, we want to help move our kids into multiplicative thinking and beyond the additive thinking of skip counting. And plus, we're going to be using the facts that we know to figure out ones that we don't know, and explore those relationships in ways that make really amazing mental math strategies that you had never thought the kids or you could do. Again, I'm Annalise Record. Thank you so much for sharing this time with me on learning about multiplication. Please feel free to reach out to me at any point. Have a wonderful day.